Now the genome is clear. The next question is control. Who reads the failure? Who asks for next change and who decided change should stay? That is the job of the orchestrator. You can think it's a brain of the loop, but it only works when the judge and genome were correctly bounded and correctly defined. Think this whole course as a one example. Each nescience adds some new modules and components, but the earlier are still running underneath. If you need to brush up those earlier concepts, just click the YouTube card in the top right corner to jump back to that playlist. Lesson 1, we define the loop boundary and place the AutoGen as the orchestration layer. In Lesson 2, we define the genome as a one-tier piece where the changes can happen. This lesson builds on those parts. We are not starting again, we are just extending the same system by adding the orchestrator. To keep the full system in mind, make sure earlier nescience are still active. This part only makes sense because that structure in there. Now let's understand this diagram. This is the control layer of the system. It reads the failure, asks for the fix, run the test, and then either keep a change or reject it. The first step is to understand the failure. The radar selects the correct genome and the latest error. This helps the next stage to make decision based on the real data and not guesses. Now the AutoGen comes in. It takes the context and suggests a small change, not a full rewrite, just pretty much focus, very precision fix. Nothing accepted because it just looked good. The system run fixed evaluation. It's a deterministic process. Keep the track what passes. The source control is a perfect example how we can build those decision trees. Anything that fails is immediately rejected and reverted. So the orchestrator is not a black box. It is a clear structure. It combines the step with AI suggestion that makes the system reliable and repeatable. Now let's go through the code and follow the orchestration flow. Focus where the control is fixed and where the AI is suggesting changes. That's a very critical area of separation. And that's where the key focus should be today. If this boundary is not clear in the code, it will cause a problem in real use. So let's go on a hands-on lab. We are now in the hands-on lab, and this is the lesson 3 orchestrator. In the first lesson, we went through the whole design of this particular example, and in the lessons, in the documents, you can find this particular markdown file. This is well documented and the diagram that we already saw. We go to the execution loop where we can find the lesson 3 one loop round. Bear in mind, this is a loop and a sequential loop. In the real life, it could be parallel, sequential, or critic loop as well. Any kind of our agentic architecture is perfectly acceptable for orchestration component. If you're not sure, I have done a series of 6 agentic architecture that you would only need for any level of agentic implementation. I'll leave a link there as well. So if you are not sure what kind of agentic architecture you need in your real life project, it will definitely come to help. But here it's sequential. It restores the genome, run the starter, repair the evaluation and baseline, and then continue the process until it reaches this point. This is where the real boundary actually between the deterministic and non-deterministic. So the focus area becomes the row reconciliation, and it helps to build the system and user prompt. That's where we interchange from deterministic solution to non-deterministic, where the fee for proposal has been passed on, and then the LLM will provide the better mutations. It will rhyme the genome candidate and rerun the candidate. That's another level of evaluation. And then it just check the date, whether it's suppressed or not, and the code improved or not. Based on that, it decide whether it need to continue the loop or it need to exit there. There is some sort of, there is a basic I would say theory. I have left it here. It will be very useful to have a quick grasp on it as well. And there is the code anchors. I would strongly recommend you to visit those code anchors and review this code, how it does actually work. Probably if we go through this code anchors, then we might extend the video up to 30-40 minutes, and that might not be very useful. So I will leave up to you how you want to validate the code anchors, but understand what backends and practices I'm implying here. It doesn't mean that this is the only one way to look into it, but this is one proven way. I mean, it has not just working for example, but this example is a watered down version of a real production system that we have implemented back in our offices. So the commands are very simple. Status, that we always fire first. And here we got a CleanLoop dashboard is running. So I'm just gonna fire the CleanLoop terminal first. Let's see, status is fine. And verified is also working. And then we'll also hit the reset. Okay, this time it does pass. I don't know what was happened with probably LLM was not responding, and we ignore this streamlit option. It's probably something different there anyways. And now I'm just setting up the reset. Now as the reset has been set up, I assume that the clean data is resetted. And then you can just go back to this and we'll call evaluate, which will provide us. Yes, that's correct. So we expect the 78 rows, 30 match, 48 missing based on the golden data we have got. So we expect this should be the one as an answer, and then we will run this max iteration. Let it run the max iteration. Meanwhile, we can actually look this dashboard as well. So let's close this group and go to the dashboard. But this dashboard is something I have added on top of it. I think everything has been processed correctly. You can actually see what current artifacts look like. You got the current artifacts. Yes, the run that we did is now picked up. And you can see the score line, probably not much to look here. It's important when we do compare across multiple options. This is pretty much we saw in earlier to understand what it did with the genome. You can see here it did something about genome, added but the real thing now at Orchestrator is about the data quality. Now what I have added is a trace decisions. It will help really to anyone to understand what decisions it is making on individual row. Let's for example, let's take this 2 to 1 and understand what this 2 to 1 looks like. So this 2 to 1 has a deterministic pass, and as we can see in 6.5 25 millisecond, it run to the deterministic pass, deterministic row, and process via the deterministic implementation. But the 210 is basically running via the mutation playbook. Here we can see the mutation playbook is actually running this particular process where the mutation is running on the first iteration of the loop. And it will also tell based on how many judge, if we are running multiple rounds, it will also explain that how the judge is taking the delta and what you will be, if you see a leak between multiple passes as well, it will help you to make good decisions, especially when you're working with the examples and the challenges which I have added. This is very important, and this is the gold standard that how the development dashboard should look like. Bear in mind that everything that matters when it comes to software 3.0 is your control. How the dealing between deterministic and non-deterministic components is being handled. That's where everything matters. So if we say here, if I basically go notation and I want to check that, okay, this source, tell me about this source, how many mutations does required. So I know that this many mutations are actually required here, and I can actually validate, okay, what this mutation look like. So it's a 114. I'm just looking at it, and based on that, I can actually understand what each mutation is going through. In real life examples or in real life implementation, there could be multi-pass mutation process as well, which will help. In our system, we have half of this agent solutions, which is a multi-pass agentic system. That means they pass across multiple agents to get the final outcome. And that provides us much more flexibility and much more distributed architecture and decision making across the agent itself who operate over the A2A protocols. And by the way, the A2A protocol is something I have also added as a course. There are 16 lessons for A2A, which is very important and the baseline to build distributed agentic design. These all solutions are fine for learning when we implement them as a single monolith agent solution. But when we go in the real world, then this agent will require distribution. This agent will require better a better segregation across each other, and the protocol connections and those things are very important. And at that time, this traces will really help, because it can actually explain that over the distributed processing, how those traces actually handle each and every use cases. Here, we are just talking about data from invoices, but it could be a real-time customer queries. It could be a real-time client call being logged, or it could be anything that you may imagine as a process or business process that you want to implement agentically, and also provide this self-correcting approach to those agents where the behaviors and everything can actually be learned along with the agentic maturity. And those things will really help with this matrices, because this matrices can actually also become a very good tuning for building better non-deterministic components. And as we discussed in the first part, that why this observability is essential before we actually broaden our horizon and increase the pressure, because currently the pressure is very little. That means we make basic rules to let LLM have its own space, but it's a very constrained space as well. When we have a better observability, then we can start building a better and broader space with a higher pressure. That means in case with the narrower pressure or narrower gauge, we manage to process 65 to 75% discrepancies. Then if we broaden the space, and if we can actually increase the pressure, we may actually reach 90-95%. That's the whole idea. Every iteration should let you increase the little bit of a space that it can wriggle around, and then it can also handle the little bit of pressure as well. So you increase the pressure, that means the more and more data will pass through those funnels and loops. And that's the whole idea. And that's why orchestration is very important with observability. If the observability doesn't exist there, that means it will always fail. You can see here we have a complete observability time span has been correctly logged, and in fact this time span and log are also something that we implement a machine learning solutions with. So our solutions also understand that how these timelines and logs been increasing or decreasing, and why that is important, because that is something help us to build the back tracing and the back testing. When we make this deterministic changes into it, how to identify whether our change is improvement or it's actually a degradation over the existing quality. Only thing you can do is the back test. And the way we can backtest and judge the backtest is by the tracing that what went well for certain use cases and what went bad for certain use cases, because it is possible that overall improvement could be there, but certain use cases may fall out of the net and actually become the worst. So it is very important why orchestration and observability goes hand by hand. Now we are getting into the serious conversation there. Beyond that point, we will have a separate lessons on observability, and we will discuss this, why and how I come to these conclusions. But it has a nascent one, and I would strongly recommend you to actually make sure you focus more on dashboards as well, not just what it does in terms of loop execution, but also understand how and why the sort of decisions been taken into dashboarding and observability as well. So let's go back on our preview orchestrator point here. There are 4 exercises, and I would recommend you to perform them, because these are the important things which help you to build idea about like score delta component, stall drum, right? These are the very important aspect, how to overcome where you face LLMs being stalled and improvements are not coming through, or how to identify the score delta using this observability. So these are the important aspects that definitely you should implement. Then one of the patience component which I suggested how to implement, I think this is going to make a real test if someone would want to attempt it. And of course the last one is also the real test, where you can actually build on, you have to learn from certain LLM and tracing capabilities that how want to achieve that. But it's worth an example, and it may not be just a 1 day or half a day business. It will take couple of passes to build those things. So watch over and over. I think Maki is wrong. You can always run with your speed, but make sure that it happens. Let's go back on our I think this passed, everything is passed. So now let's go back on our presentation before we conclude there. Now you can see how the loop works. The orchestrator reads the failure suggested changes and let the system decide what to stay. Next, we will add tracking. We have already discussed a lot about tracking, but then we will properly discuss it. This will help you to see how system is improving, getting stuck, or giving wrong signals. Thank you very much for staying in this lesson. And if you like it, please make sure you like and subscribe and press the bell icon so the next lesson straight away come into your notification list or your timeline. I'll see you in the next lesson. Thank you very much.